Tips on Proof Writing Continued, Part 2. On page 69, number 12, we have a proof where we're given that we have a line and we have one line that's perpendicular to it and two angles that are congruent, and we have to prove that this ray here is perpendicular to this line. So the ideas that I'm thinking of right now is that since we have angle 1 and angle 2 congruent, then that is going to imply that angle 1 is also equal to 90. Now this isn't a formal proof, but now I know that since 1 is also 90, then we definitely have a perpendicular line. That just gives me an idea of tracking ideas, jotting down some ideas so that I can refer to that. That's going to be like one of my main steps that will connect the beginning steps, the given, with the step at the end. Next, in green, I'm going to write down the given. DC is perpendicular to BD, which means that angle 2 is equal to 90. Now, that is a given. Be very careful about writing what you have to prove on your drawing, because sometimes, especially if you're starting out, you start to think that whatever you write is given. In red, I'm going to write what I conclude. So we have the given, we have what I'm concluding, and now I know that AB is going to be perpendicular, but I still have to go through all of the steps of writing the proof. So, starting off with the given, DC is perpendicular to BD, and angle 1 is congruent to angle 2. In this proof, I showed the given all in one statement. Next, I can conclude that the measure of angle 2 is equal to 90 degrees, and that's by the definition of perpendicular lines. This sign means perpendicular. In the reasons, it helps to use symbols as much as possible, just so that you don't have to spend lots of time writing everything down. Finally, since angle 1 is congruent to angle 2, we could, and in the book it shows this as well, just to help ourselves see the substitution better, you can actually write that this means that measure of angle 1 is equal to measure of angle 2. It means the same thing. It's still considered given. It's not considered a conclusion based off that. And so what you can say then is, since measure of angle 1 is equal to measure of angle 2, then measure of angle 1 is equal to 90 degrees as well. Now here is a debate that I've had with many of my students over this type of problem. If we have 1 equals 2 and 2 equals 90, is that transitive or substitution? Well, I've heard arguments on both, so if you're a math professor watching this right now, you might roll over and groan when I say that you can use either one. Finally, we have that as a result of measure of angle 1 being 90 degrees, as I indicated with my red marking in my drawing of the conclusion, then BA is perpendicular to BD by the definition of perpendicular lines. A note about definitions. Often in proofs we have definitions as something that has a conclusion and a given, and we can switch conclusions and givens of the definitions and use them interchangeably. Here we're given that we have perpendicular lines, so as a result we have 90. And it's also true in the same definition that if we have 90 degrees then we have perpendicular. Now, that only works for definitions. That doesn't work for theorems. For theorems, there are two different theorems for situations where you switch the conclusion. But definitions, switch the conclusions all day long. You can still use them interchangeably.